So today, let's see what it takes to repair this battery pack. Let's get it back together. So one thing I'm going to do before I insert the new cell and start to connect everything back up, I'm just going to take this little small rotary tool, which is really handy for tight spots, and it's not real aggressive. And we don't need nothing heavy duty, just something light duty. I'm just going to go through and clean up. All the spots like so. That's on the positive and the negative terminals. And if you can see that, they're all flush again. So I'll go through and do all these, and we'll be back on the bench to clean them up with alcohol, to prep them and get them ready. So back after cleaning up the battery spot welds in the garage pretty well, I'm just going to go through with some high percentage alcohol and clean up some of the other residue. And after we do that, we'll be right back. So now after cleaning the cells up, it's time to prep it to put back together. And of course, we needed only one cell. After checking all these, it remained true that we only needed one cell, and I got that one from 18650 Battery Store. They're not a sponsor, and they didn't send me the cell for free. I just simply ordered it, and the reason I mention them is they actually are one of the only places that this cell was available, so I did appreciate them having it in stock. It made this repair a lot easier than trying to find something that's very, very similar. I would always rather put in the exact replacement cell. So at this point, sometimes I go through and use a little magnet that I real quickly soldered a little wire on, because it does kill the magnetism. But you can use a magnet and you can go through across each individual cell. You can't see it on the bottom, but from bottom to top, you just have to make sure you keep your polarity right, of course, and watch what you're doing. But this is a little trick that to boost up individual cells, even though you have them disconnected. If you have one that goes low, in this case, it's really fine. We didn't really have any cells in really bad shape. We just have to be careful before we do put this back together. I do want to make sure we're pushed in and we're disconnected, like we're in series mode for 60 volts. Because we do know that the way this one had a cell low, that all these are around 4 volts. I can't remember if I showed this on video earlier or not, but a lot of these were around 4 volts with that one cell being 0. And these others are around 3.2, I was thinking. Yeah, most of them are 3.2. So the battery pack in all is pretty balanced. It's just that that one cell caused the issue with this one section of 20 volts. With it going to 0, the rest of them drifted up until shut-off point per cell at over 4 volts. So it all made sense the way it acted. So what I have to do is, they usually ship these around half. Yeah, and 3.5. They're gonna send these, you know, usually around half or so capacity. Depends on the manufacturers, but they don't never hardly send them fully charged. So this is another time where your magnets can be helpful. You can put them in a battery holder or just put your magnets across here. I'm simply going to let this one sit aside and charge up to 4 volts to get it ready to put in. We'll let that sit there and come up to 4 volts, and we'll be ready to put it in. So here we go back now with everything cleaned up on the battery pack, and the replacement cell is charged up to 4 volts. So as we replace that cell, and we'll push the cage back around. I did just go ahead and take off where the orange was connected to, since it was a problem. We'll just reattach it, like we gotta do the green as well as this red for the fuel gauge. And there we go. Everything is back down. Some of these I might have to just add strips. Some of them, the U strip might be just fine. Some of these we have to do one before we bring the other one down, if that makes sense. We have to do this one and insulate it. So I am having some trouble with some of the used cells taking a good spot weld, and I don't have the best spot weld set up still. I worked on my own and I have a video for it. I was using capacitors, just super capacitors, as a small portable, I guess, spot welder that would do a few spot welds. But for this setup here, I actually have two 12-volt batteries. I just got my power supply keeping them charged as we're going through here, and I got it with Banggood about sending me a spot welder, and at this time they're not really offering any to me. They are sending me a 60-volt power supply, which I'll be glad to review. I'm happy to get that as well. But I did want to try a spot welder because I had a few battery packs. I was wanting to see how good the more industrial or benchtop spot welder does. But on some of these I might just have to go back and solder. And I know that's not popular, but I've mentioned in a few videos that I would always go with a high, at least a 100 watt, if not a 200 watt iron, and just solder up really quick. I know I shared that on some Ego battery pack repairs and things, and I'll always use a rosin flux. It also helps it adhere quicker and easier, and you don't have to heat it up quite as much for it to take. And you might see me resort to a few as we go through here with a soldering iron, but that's going to explain it right there. That's why some of these might not take well. I'm having trouble with some of them taking. But other than that, I'm just going to use the spot welder and just go through and do it. This contactor just pulls in. I just control my time more manually on this one. Hopefully in the future, maybe I'll wait on Banggood to send me one, but maybe I'll have one with electronic time control and plug into an AC power supply. But my next step here on this one is I'm going to put some of this 3M glass cloth tape across here, and then I'm going to put some Kapton tape over that, because you may or may not remember, this is one of the ones that had a piece of mica over it. I do have some pieces. It's kind of messy and flaky, and instead of using double back tape to do that, I think I would like better just doing it with the high temperature glass cloth tape, and just have some extra protection here with the Kapton tape. So I'm going to do that, and we'll be right back and go to the next step. So sometimes I just put my finger here and make sure I put pressure down. I want to have a good low resistance contact path when you press. And since I can only press down for just a split second as my contactor pulls in, I got to make sure I'm putting good pressure down and then right back up. I do want to upgrade to a solid state device. This is just what I have now. I've used it for a few small jobs and it hadn't been bad, but I realize on a battery this size I don't like it at all. I do have to come back and solder on my balancing leads as well as my fuel gauge, of course. I tried to clean this up as much as possible to try to save this strip. Let's see how it goes. Oh, I forgot that's the positive side. So I went off of it's what happened there. There we go. I actually went off of the, let's see. I actually went just a little bit off of it and didn't realize it, so it made a bad connection. It made a bad connection there, so it just blew through the, what was left of that strip. Trying to avoid the solder, but I actually couldn't go that far with that one. But I think that's okay. I think it did grab good. I do have to just take a little time now and connect our monitoring leads here. So some of this will be fast forwarded so you don't have to watch it all. I am going to use my 140 watt iron. Put some rosin flux on there and I'm going to try to give it just a little bit of a puddle there. Clean this part off. So some things from watching a video and do better than I did. That yellow wire probably would have been better to do first. I was just trying to come across, but that yellow wire is one that would have been better first, and then put the tape on and then work across. So just thought I'd mention that. Besides getting a better spot welder. And even though you typically don't want to cool a soldering joint fast, when it comes to batteries, I will at least blow on it, and sometimes even a cool damp paper towel. But we're not getting these warm at all. I can touch them immediately. But it does matter, at least to me. I would rather cool the joint than let the battery overheat. So it will definitely cause degradation. The next is green, going to this one. And we are going to have to add some to that one. but I do still have to balance this out. These right here is going to be really close to fully charged since I charged them all at the 4 volts. And these right here are going to be they're around 17, 18 volts. They're going to be charged up. I want it to be balanced before I release this. Right now, releasing this will put a lot of load on the cells that's charged and put a lot of current out of those and a lot of current in these that are 2 or 3 volts lower. So definitely something we want to make sure we keep pressed in and to keep them in series rather than parallel until we get them all up and balanced well. So I'm going to hook the power supply up. 20 volts, current limited to about 1.5 amps. And this is always the plus side on this side. All 3 of these, I mean, is positive, and all 3 of these are negative. So with 20.1 volts and 1.5 amps, we will let that's around 18.1. It came up to that level. So it's going to build, and we'll do this one and this set real close to balance, and then we'll release the override we have in here for the series being 60 volts. And we'll be back to see how it does. So charging these up, they should be fairly balanced now. Within 1/10 of a volt anyway. We should be able to now release and put them all in parallel. And those will absolutely equalize out. And if we push this in and jump this, there's a 61 volts. So I actually want to just put this back together so it'll be easier to put it in a tool and run it down. And then of course we want to recharge it and just make sure everything is good. I cannot test it myself on a 60 volt tool at this time. I don't have one, of course, and I can just give it back to my buddy to test out at the 60 volt level, that is. So this battery did test out fine in my 20 volt blower, and it's quite a battery, so I thought it showed down to 1, but it bounced back up to 2, so I only got it down to 2 bars. But we'll see if this charges from flag power. I charge it up. I know it'll take a while, but we'll let it charge and we'll come back and we'll see how it does. So back now after about an hour or so, topping off this battery, and it's fully charged. And let's actually check the level here. 20.87. So I hope you enjoy this FlexVolt from the look inside, disassembly of that cell replacement and the reassembly after that. So hope this helps somebody else with the same issue. I will say I didn't take a lot of time looking to the BMS board other than the way that the battery pack changes the cell configuration there. But I also did a 20 volt max battery repair. This exact pack here, maybe a year or so ago, and it's been a pretty popular video. And I explained there how the battery has the B plus, B minus, your cells, a little bit about your TH and ID for your thermal going back to your B plus, and your ID ohming back to B minus. And it has a lot to do with, it seems like the capacity of the cells. For example, you'll see type 1 or type 2 cell depending on apparently the current rating, or at least the capacity, should I say. And it looks like DeWalt, and correct me if I'm wrong out there, somebody knows more about it, but it looks like DeWalt's just using a resistor, as discussed in that video, to just show you idea of what pack is installed. And it might be possible that when something goes on with a pack, that switches off that ID, so it's not available and shuts off. But still not 100% sure at this point. But if you wanted more information on the BMS, I have looked into the 20 volt a little bit. It is different from this one, similar terminals, but they are doing a strange thing with C1 and C3, of course, with the insertion of into a 60 volt tool. So definitely slightly different, but nonetheless, there is some information about the DeWalt terminals, if interested, that might help you some. So hope you enjoyed this video. Thanks so much for watching. If you thought the video deserved it, please like, share, subscribe. Guys, I'll also have some links down in the description of the video for some of the tools and items that I think's interesting and that I use a lot on my bench. If you found them useful, any links you do click on supports the channel and it's greatly appreciated. Thanks so much for watching, and God bless.